Today I'm in Flint, Michigan with Brady and Eric from iAfrady and the CEO of Propeller, Rory, and we're going to be doing a head-to-head comparison between traditional photogrammetry with drones and Propeller's PPK processing solution using their AeroPoints. Let's fly!
What we're doing here is this first AeroPoint we're placing on site is going to tie all of the AeroPoints, all of the ground control to the local coordinate system. Now the AeroPoints, what they're doing now is they're soaking up GPS, raw GPS. They're going to act as the PPK base station for the drones. We're going to take those photos and we're going to take this AeroPoint data and we're going to really tighten up the position and the trajectory of that drone, right? So we're going to get really accurate positions on every drone. And then these AeroPoints, of course, are going to act as a closed loop sort of ground truth in. So we're going to see these targets in the photos and we're going to dial in the last of those millimeters or inches to get really tight accuracy using a handful of these across the site. So the process for using the AeroPoints is literally as simple as putting it on the ground and pressing that one button. It starts to log, it's soaking up GPS data. It's solar powered as well, so Eric was just saying he hasn't charged these in a month because they're being used during the day. It's nice and sunny here today, so it's going to sit there and keep itself charged and soak up GPS. Once we've finished the survey, we press that button again and it connects to your phone and uploads the data to the cloud. No SD cards, no emailing, just really seamless workflow.
So with traditional ground control points, we're gonna have to set something at every corner. How many acres are we dealing with here?
This site's 200 acres.
I would say at least 6 ground control points, 1 at each corner and probably 2 in the middle. So This is the northwest corner.
Correct.
And so let's set a target here. So grab this corner here. Ah, come on. Okay, cool. So we'll record point number 1 here. Good.
Perfect.
All right, so now let's head over to the northeast corner to set the next control point.
Do you know why they're grey, Eric, not white, these targets?
No, I don't know.
So in sun like this, if it's white, when you take photos with the drones and you look at those photos, the white squares blow out, right, and it kind of flares in the lens. So this is a 17% grey, which is the right amount of grey to make it seem white when you're taking those photos. So it just helps the contrast. So if anyone you see anyone using white and black targets, tell them it's too bright.
Meanwhile,
Lost the grommet on this one, but it should still hold, yeah. Got some rocks underneath.
Better.
All right.
There we go.
Cool.
Probably somewhere right here.
This is concrete, dude.
Sure is.
Let's go back over there. Maybe that'll actually work.
That'll probably help us.
Try that. I think I got it. All right, I don't think that's gonna move. You know what we used to do when we didn't have nails?
What?
We used to just throw big rocks on the vinyl targets just so they wouldn't fly away. It would sometimes work.
You come back and they're gone.
Well, we would come back and it would be like this. It would be
over.
like half folded, yeah, because some of the rocks flew over.
It's not gonna work.
Yeah, that's why you gotta use nails. Yeah, that's, if we do this with the nail and the rock, it should be all right.
And it's not gusty.
Yeah, it's not crazy gusty today. Yeah, that one's pretty good.
That one sounds better, yeah.
Yeah, it might be just we're getting unlucky. I'm gonna put some rocks here in the corners just so that it helps with stability. All right, go ahead and shoot it.
Perfect.
So this is our third one, same as always, just very simple. Stick it on the ground, press the button. Again, you don't need to shoot it in, right? Because it's figuring out its own position.
I guess we can set one here. This should be a little bit easier to set. Cool. All good? All right. Yeah, we really walked this whole site basically.
Pretty much, yeah. This is as far south as it goes. Yeah, we put one over there, and then this is about as far as you're gonna get.
All right.
Perfect.
Go for it. Was this number 5?
Correct, 5.
Nice.
The reason we only need to use 3, we really don't even need 3. We need 1. 1's the absolute minimum. Then the second and the third allow us to really understand the accuracy of the model as control points. So when you're processing with targets, whether they're AeroPoints or normal, you can set a target as a ground control point, which means it's actually locking down the model. or you can set it as a checkpoint, which means it's not locking down the model, but you're validating if the model is accurate in the end. So when you have more than one target in the model, like what Eric's doing today, we're able to optionally choose to use some of those as checkpoints, and that's really the only way to truly understand how accurate a drone survey is from photogrammetry.
And this is it, huh? This
is number 6.
Number 6. Here we go. Pretty sure Eric and Rory are done.
I'm sure they're long.
They've been done. They're just waiting on us. So. All right.
There we go.
Shoot her in.
Perfect.
All right. Awesome.
All 6.
Cool. Let's head back and catch up with Rory and Eric.
Yes.
Okay, so today we're going to be flying the DJI M4E, which is their newest enterprise drone. So it's designed for mapping. It's got the RTK GPS built in. Really great camera, good flight time. We'll fly this drone today at about 350 feet. We expect it to sort of the whole 200 acres to get captured in 25-30 minutes or thereabouts. So even though it's got this RTK built in, we actually don't fly the drone in RTK mode. To fly it in RTK mode, you need a separate base station that can send the corrections to the drone. Our Propeller PPK workflow doesn't need that, so the AeroPoints act as the base station. Now this guy is just operating in PPK mode, which means it's soaking in all of that GPS data and just storing it on the SD card. And we mash the AeroPoint and the drone data together on our servers once the flight's finished. So it takes away one sort of piece of the puzzle, which is needing a link from the base station to the drone in real time.
So we're going all the way up to, there's an intersection up there in the northwest corner of the job, and then there's sort of like a ditch. It's the edge of our limits for destruction, and that's over there in the northeast. We're gonna follow that all the way down, and then there's just another intersection down there. So it's pretty much just the out limits of the job.
We're going to take those files, all of the GPS files, all of the photos, the AeroPoint files, and we mash all of them into one really accurate data set. So every photo gets post-process corrected by Propeller after the flight. It's fairly involved, do a really good job of this. You know, as you can imagine, if the drone's getting tossed around in the wind, you've got the GPS antenna on top, you've got the camera sensor. The GPS antenna can actually move relative to the camera sensor, and so we need to calculate the exact position and the lever arm, all of the offsets between that sensor and the antenna, so we're getting every millimeter we can. And so we do all of that so customers don't have to think about it. It's just put the AeroPoint down, fly the drone, upload everything to Propeller, and we return new models that are, you know, within 3 centimeters or 1/10 of a foot. The first AeroPoint we used is essentially helping every photo that we take in the sky become really accurate, and it reduces the need for control on the site. It doesn't eliminate the need for control, and we don't think anyone should be marketing that or saying that out loud. Like, you always need something. But this is just, you know, a more practical amount of control.
All right, we're getting ready to come back to home here. Just finished up.
Nice. Very good. How many images did we get?
It was 937, I believe.
So that covered all 200 acres, right?
Yep.
Nice. There it is, way up in the air.
There we go.
Done.
All right, so I got to remove all these targets. Oh, there we go. Got 5 more to go. Okay, here we go. Oh, good. Last one here. All right, and that is all the vinyl targets.
All right, so I just have to stop this logging, one button. That's it, no longer logging. We're done. That's the AeroPoint. Okay. Done. So when we were making these, we actually we beveled the edges and weighed them down a little bit so that they don't blow away in the wind. It's just the right amount of weight, and those beveled edges keep them nicely on the ground.
All right, now that we're done picking up our targets, we're gonna process this data set twice, once using traditional ground control points, and then the second time using Propeller's PPK solution with the AeroPoints.
Great, let's see. Hopefully they turn out to be really accurate.
All right, so now it's time to go over both data sets. I'm gonna walk you through how Propeller processes the data on their end, and then we'll go over the results. So we're gonna start by creating a new survey, and we can name the site, so we'll name it Buick City, and then we'll come down to Photogrammetry survey processing. And when it asks us for the processing method, we're gonna be using the Propeller PPK corrections.
We'll go ahead and hit next, and then we can drop and drag all of the images. So here they are, they're all loading. And we also want to make sure we update the trajectory files to ensure the PPK can align everything using the timestamps found in the drone's images. And here we can see a plot of where all of our images are located on our site. And all of the file validations look good. We've got green check marks on everything, so I guess we can move on to the next step. So I'll go ahead and click next. And now we're going to add the AeroPoints plus the CSV file. The CSV file is the survey that I did using my GNSS receiver, and we're going to be setting all of these points as well as some extra ones that I took as checkpoints to compare them to the overall data set that was influenced by Propeller's PPK solution and the AeroPoints. Okay, next I'm going to select the AeroPoint flight, so I'm just going to search up Flint. And there we go, Flint, Michigan. And so we're going to process everything using the local site survey benchmark. And we've selected the first AeroPoint because that is where we had our local coordinates set up. For measure 2, we're going to be selecting the top of the AeroPoint. We then have the state plane coordinates here. And then down here at the bottom where it says PPK drone flights, we can see we've got 2 flights here because we ran 2 sets of batteries for this project. All right, I'm going to go ahead and hit save. Now I'm going to be uploading our CSV file from our GNSS receiver. Remember, these are all going to be checkpoints, so they're not going to be influencing the data. All right, so I'm going to go ahead and assign all of these columns. This one's name, this is northing, easting, elevation, and purpose. And everything is landing right on top of the aerial with all the images, so we know that everything is coming in correctly. I just now have to change everything from ground control points over to checkpoint to ensure that they don't influence the data. I'll go ahead and just change all these over to checkpoints. And down here at the bottom, these last 3 points, these are the arrow points, so we'll leave these ones alone as ground control points. All right. We'll hit next. So in terms of filtering, we'll use just the equipment filter. All right, everything else looks fine. We'll hit next. Down here at quality assurance, we can select the level of strictness that we want Propeller to basically check our project at. Let's just set this to strict. There's no harm in having them double check our work. And then we'll click submit survey for processing. And there we go. Now our files are being uploaded. Looks like it's going to take about 5 minutes to upload. And so we'll probably get an email from Propeller in the next 7 to 8 hours, letting us know that our project has been processed. And then we can compare the results between the AeroPoints using Propeller's PPK solution to what we would do with traditional drone surveying. All right, before I show you the data, I want to let you know that I'm going to be in Las Vegas, Nevada on September 2nd to the 4th attending Commercial UAV Expo. Commercial UAV Expo is one of the nation's largest drone mapping conferences, bringing together companies and industry professionals that are familiar with drone surveying, providing you with lecture sessions that highlight how we do drone surveying and maintaining a high level of accuracy. I'm going to be there along with several members from the survey school, and I'd love to invite you to join us in Las Vegas for Commercial UAV Expo. If you use my promo code Rami100, you'll receive $100 off either a full conference pass or an exhibit hall pass. I look forward to seeing everyone in Las Vegas for Commercial UAV Expo. All right, so the data is done processing, so let's take a look at it inside of Propeller. All right, so you can take a look here. This is the ortho image, and it is georeferenced correctly into our job site. Taking a closer look here on the left, I can turn on the terrain layer, and this will actually turn on the DSM. So now if I zoom in and I start to rotate around my job site, I can actually see the 3D elements. Here, if you look at these stockpiles, you can really see everything pop, and everything is aligned perfectly between the ortho and the terrain model. Now, if you're trying to work with more precision, then you can turn on the point cloud. There we go, everything is populating, and as I zoom in here, you'll see more points start to populate. There we go, more of the points are now populating, and we can decrease or increase the point size. We can also turn on our camera positions, which will show us where each of these images are located. So there we go. Each one of these camera positions is where an image was taken, and we can see the grid of the drone's trajectory. Now, Propeller will do an analysis on our site and give us several map outputs that we can use. So if I turn on the elevation map, we can see that populates to show us where the high points are on our site, and it can show us where low points are. So here, this goes beneath a bridge, and you can always adjust the colors to make the elevation map to your liking. We also have a gradient map, which could be really good for identifying where brake lines should be. Drastic changes in elevation are also pretty prominent here. So again, here in this area where there's a bridge, We can see an extreme change in elevation. And finally, contour lines with contour labels, so we can actually see what each of these contour elevations are. And this is really good for someone that's trying to do a topographic survey. It's a great starting point to be able to see the contour lines while you're still inside of Propeller. You also have the option to add points on your site, and you can add different properties to it, like a name and a description. You also have the option to draw in lines, so perhaps you want to do some feature extraction on some roads, you can easily do that. The polygon feature could be really good for identifying, different structures on site, like buildings, or in our case, maybe the remains of an old building footprint. We can get the surface area of it, so that's really nice. We can also do a cut cross for a profile, so we'll do this area right here where that bridge is. So you see how the line goes down and then back up, and Propeller has given us some sloping information that we can utilize. We even have the ability to do stockpile measurements. So I've just identified the bottom part of this stockpile. So now Propeller will calculate how much volume we have here of material. And there we go. We can now see we've got about 10,500 cubic yards of material. And I believe you can actually just hold down shift and click, and it will automatically identify the stockpile for you. And there we go. It actually did everything automatically for us. So this one is about 1,700 cubic yards. The one other thing that you can do with Propeller is actually import your design CAD drawings and visualize them with your geospatial data. So if I come over to designs, I can actually open up some of these drawings. Now again, this is not my project, this is iAfrady's project, but they do have some CAD drawings in here, so we're going to take a look and see what it looks like. So yeah, it looks like there's some kind of design happening here, maybe some buildings that might be coming in here, and I can rotate, and if there are elevations associated with the CAD drawings, they will match what is on our ortho. So the line work down here, there's no elevation, that's why it's set to 0, but this stuff up here does have some elevation. So that's pretty cool that I can see all that. And if I actually come up here to the top where it says view on mobile, if I click on this, I get a QR code. And so what you could do is take your phone and you can actually click on that, and Propeller will load up the project for you on your phone. And there we go. I can actually see the ortho image here. If I tilt it down, I see the terrain. And then in the layers here, I can actually turn on and off different layers. So in the design here, we can turn on those design CAD drawings that we were just looking at. And there we go. There they are. So this is really good for anyone that might be out in the field and they want to overlay some of the CAD drawings on an existing ortho image. They can really visualize everything and see exactly where it all lands. We also do have the same tools here, so you can add points on site if you needed to. Maybe you want to measure the elevation of a certain point. You have lines, polygons, even photo. One other thing we can do is if we have multiple surveys that we did of the site, maybe we visit the site often, you can actually load up all the other orthos that are associated with this site. Pretty handy, pretty nice. I haven't actually seen this with any other platform, so it's really cool to see how integrated it is with your mobile device. And so the final thing that I really want to look at is the accuracy. Does Propeller's PPK solution and photogrammetry processing software compare to traditional drone surveying and photogrammetry software? So what I've done is I've processed my own version of this project. I've used the same imagery, but I used my control instead of the AeroPoint control points, and I measured 11 checkpoints on the site in addition to the 6 ground control points that I set. And as you saw, I brought in all of the data to Propeller that I collected, as well as processed this in a different photogrammetry software. And so let's see the results. Let's see how those checkpoints look on both datasets. So we'll come down over here to outputs and the processing report. I'm going to open this up. So here we have the overall site. Taking a closer look, we can see the arrow points that were used as ground control. And then around here with the flag, these are all checkpoints. So there's the entire site. We've got 3 ground control points and then 17 checkpoints. Coming down here to the accuracy, we can see the expected ground control accuracy, or the RMSE, coming in at 0.042 feet, which is about 1.2 centimeters. And the average difference for the ground control points is 0.034 feet, which is 1 centimeter. Okay, so now let's look at the checkpoints that I measured with my GNSS receiver. The Propeller PPK solution gave us an average error of about 0.115 feet. So with a tenth of a foot of error, error, we're looking at approximately 3 centimeters. Okay, now let's take a look at the same data, but processed with a different photogrammetry software. So here we go. We are in a completely different software, but it's the same exact data set. You can see here is the ortho image. I used the same images from the M4E, and in 3D here, this is the point cloud. I just have the point sizes pretty small. All right, and so now I'm going to process out the quality report, and let's take a look at the accuracy. So the 6 ground control points that I have an accuracy of about 0.44 feet, which again is about 1.2 centimeters, pretty much the same thing that Propeller gave us. And the overall checkpoint accuracy came in at about 0.08 feet. So just under 3 centimeters, which is pretty much the same as what Propeller got. So here you can see a little bit more detail about the ground control points. And then coming down here, we can see the 11 checkpoints that we used for this software. Special thanks to Propeller for sponsoring this video and giving us an opportunity to work with a real client like IFRAD on a real construction project. If you'd like to learn more about surveying and grow your knowledge about the fundamental principles of surveying, then be sure to check out thesurveyschool.com to join our premium community. Thanks guys for watching, and I will see you all next time.